Alright everyone, welcome back. This is the Chemistry Girl, and today we are doing an ionic bonding and naming review. So I have 4 problems here on the board, these 4 problems. And so actually what I would like you to do is just pause the video right now. For the first 2, you should draw or write out the chemical name for those first 2. And then for the second 2, you should write out the chemical formula based off of those names, and you're going to need a periodic table and a polyatomic ion sheet, which I have on the left hand of my screen. So take a couple minutes, try to figure those 2 things out, and then come back and we will go through it. So now that you're back, what I want to go ahead and do is I want to go ahead and start with, as you'll notice, I kept the same OH ending for each of these, and I just want to show you the key difference between number 1 and number 2. So we're trying to write out the name of these 2 chemical formulas. These are ionic bonds, and the reason we know that they are ionic bonds, ionic means that they are made up of ions stuck together. And the only way that these ions could be stuck together is if we have a positive ion attracting to a negative ion, and we know that positive and negative attract, and so an ionic bond is going to be a positive ion or a cation attracting to an anion. And most of the time, a cation is a metal and an anion is a nonmetal. That will not always be the case, but most of the time, those are the patterns that we see. And so, we see in this case, iron is the metal, which is going to be the cation, and then we have a group of nonmetals, and that group of nonmetals is going to be the anion. And so, the first thing that I want you to notice is that iron is right here on the periodic table. And so the only difference between numbers 1 and number 2, because calcium is also a metal, and it's bonded to a group of nonmetals, which is the OH, the only difference between numbers 1 and number 2 is iron is in the middle of the periodic table, whereas calcium is over here. And so these things we actually treat differently because I'm going to go ahead and box this section of the periodic table, and it's going to come all the way down to about here and over. And these metals that I just boxed are called transition metals. And transition metals have charges that vary. They're not always the same. And because they have charges that vary, I therefore have to write a Roman numeral to indicate the charge of the metal. So when I write out the name of iron hydroxide, this, I'm going to write the name of the metal, and then I'm going to leave a space for a Roman numeral, and then I'm going to write the name of the nonmetals. In calcium, I'm just going to write the name of the metal, and I'm going to write the name of the nonmetals, and I'm not going to include that space for a Roman numeral. And the reason I'm not going to do that is because calcium is outside of the transition metals section. Calcium is in group 2. So if this is group 1, this would be group 2. In groups 1, 2, and 3, these metals do not have to have Roman numerals because in group 1, the charge is always positive 1. In group 2, the charge is always positive 2. And in group 3, the charge is always positive 3. But in the boxed section, we know that the charge varies. And so therefore, we'll need a Roman numeral. So what I'm going to go ahead and do for the first one is write out iron, and for the second one, I'm going to write out calcium, because we know that's the name of the first 2 words, iron and calcium. I'm going to come back to the Roman numeral in just a moment. Whenever I see a group of nonmetals like O and H together, I automatically think to come over here and look at my polyatomic ion sheet. And so we see the name of OH is hydroxide. So I'm going to write hydroxide for the second word. And so for number 2, I'm actually now done. I totally completed number 2, calcium hydroxide. However, for iron hydroxide, I'm going to need to include some Roman numeral. And remember, the Roman numeral indicates the charge of the metal. So I need to figure out what the charge of the metal is. So I'm going to do that down here below. So if I have iron OH3, the thing that I do know is that this 3 tells me that this compound is made up of 3 OHs and 1 iron. That 3 OHs are bonding to 1 iron. And remember that we said that ions that are stuck together make up an ionic bond. So these OH ions are negatively charged, each -1. And so the total charge of the whole thing needs to equal 0. And so because these add up to -3, to cancel that out, we need the iron to have a charge of +3. And so that must mean that the Roman numeral that goes in this space is a 3 to indicate that the charge of the iron is +3. And now I'm done with number 1. And so the only difference here is that in the first case, for the iron, I'm including a Roman numeral to show the charge of the iron, whereas in the second case, for calcium, I don't have to do that. Okay, let's move on to tin chloride and sodium chloride. So again, I'm going to do this in blue so that we can see a little bit of a difference here. I want you to go ahead and find tin and sodium on the periodic table. We notice that sodium is not a transition metal, but tin is it's actually a post-transition metal. And so therefore we see that tin contains a Roman numeral while sodium does not. Okay, so remember that the Roman numeral tells me the charge of the tin. So the tin is actually +4. The chloride, if I do that in yellow, the chloride's over here. And so we have a metal bonded to a nonmetal, and the chloride is -1. So remember that the charge of this column is -3, the charge of this column is -2, and the charge of this column is -1. And so, just like I said earlier, if we want all of this to add up to equal 0, we're actually going to need 4 chlorines, each with a -1, -1, -2, -3, -4, bonding to 1 tin, which is +4. So that the total, if we add up everything together, so if we take all of these ions and we stick them together in one compound, their total charge would equal 0. So to write out 1 tin, I would write this. To write out 4 chlorines bonded to the tin, I put a little 4 to indicate that these 4 chlorines, or chloride ions, are bonding to 1 tin ion. So then lastly, let's look at the sodium. I'll do this in orange. So the sodium's over here. It has a charge of +1. Okay? We just said that the chlorine has a charge of -1 because it's in the 7th column. And so when these two things come together, we only actually need one of each. And so to show that I have one of each, I'll only write sodium NaCl for chloride. So that's it. That's your mini review. I hope that was helpful, and have a great day.